Okay, let's talk about one-sided limits now, okay? And then hopefully where a limit doesn't exist, those are the other two topics. So if you're keeping track, we defined limits, and you kind of worked with their general concept. Now we're going to talk about one-sided limits, and then we'll be able to talk about when a limit doesn't exist, because they don't always, okay? So let's talk about one-sided limits. I'm just going to draw some kind of piecewise function here just to show you. Bam. Let's say we got this going on. Let's say that's 2. Let's say that's 4. Let's say that's 10. Okay? So here's what a one-sided limit looks like. And you'll probably guess actually what's going on here. They do the notation to be helpful. So let's say I say that the limit as x approaches 2 of f of x. Okay, this is f of x. And I'm wondering what that equals, but I'm going to put a little negative sign up here in the superscript, all right? So just see if you can figure out, I'll give you 2 seconds, see if you can figure out what that limit is. So what this means, and this is how it's pronounced, is this. The limit as x approaches 2 from the negative side, or from the left side, okay? So what you're doing here is you're following these y coordinates, and we're getting closer and closer to 2 from this side, from the negative side. And guess what value we're getting to? 4. So that is the limit. But Mr. Hayashida, it doesn't equal 4 right at 2. Yeah, kid, that's right. But we do not care what y equals for limits. We only care what y approaches, right? Approaches. As buenas noches and porcupine quills, right? Okay. Now, there's an analogous notation. If we approach 2 from the positive side, guess what that equals? Well, I don't know. Let's see. Blah, 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 blah. As we approach 2 from the positive side, oh, goodness, it's 10. Okay? That's one-sided limits. You're done. There's nothing really much more to say about them. Let me just make sure that's true here. Yeah, I could do that thing. Okay, so it doesn't matter, by the way, what is happening right at 2. Like, watch. I could fill this in and empty that one, and these answers won't change, right? Because do we care what y equals there? No, we only care what y approaches, right? By the way, with it like this, what is f of 2? I'll give you 2 seconds. Did you say 4? Because right at 2, don't look at the open dot, look at the closed dot, and we're at 4. Okay. So let's just say, I don't know. Let me give you one like this. Bam, bam. So here's 7, here's 8. So if I have the limit as x approaches 7 from the negative side, guess what that equals? Or, oopsie. Or the limit as x approaches 7 from the positive side. Notice that they're in the superscript, right? Like you wouldn't, if you just write x approaches 7 and then a plus sign, that'll look a little sort of weird, okay? Anyway, can you tell what these are? They're both 8. Because as I approach 7 from the negative side, I'm getting my y value is getting closer and closer to 8, and my as I approach from the positive side, getting closer and closer to 8. And that's even though, like I could put a little plus sign up here and say that that's 16. Even if the function equals 16, we do not care what y equals. We only care what y approaches, right? Okay, so that's one-sided limits. Really, I'm done. If you get that and you get the notation, you're going to be good to go. It does allow us to talk about when a limit does or doesn't exist, okay? So let me give you that. By the way, we'll do notes on this when I'm back, okay? I'm just trying to get the concepts across to you, give you a chance to practice them, and then we'll do notes later, so you don't have to be trying to guess what to write down right now. Okay, so let's talk now about when a limit doesn't exist. Well, actually, let me tell you when a limit does exist, okay? A limit exists if the left-hand limit and right-hand limit exist and equal each other. That's it. A limit. Oh, jeepers! What happened here? Hello. Oh, come on. Oh, I'm still going. Okay, my screen locked up. I hope that you just got that. So I'm just going to pretend that nothing happened here, and hopefully that is the case on your end. So a limit exists if the left-hand limit equals the right-hand limit, and they are equal to each other. I might not have mentioned this. Can I come over here? I'm just realizing. So they will call, as you approach from the left-hand side, they will sometimes call this the left-hand limit, okay? And as you approach from the positive side, from the right, they'll call this the right-hand limit, all right? So, sorry, I'm pretty sure I did not define that. So when you see the negative, you can think of that as a left-hand limit. And when you see the positive, you can think of that as the right-hand limit, okay? Just because that's where you're approaching from. Okay, anyway, so let's just try to break this thing and we'll see when a limit doesn't exist, all right? So here, there's really just three cases, and one of them, two of them would occur to you. Like, check this out. If you do have that piecewise function, here's 10, here's 30. Does the limit exist at 2? Well, let's think about it. Does my left-hand limit exist? Yes, it does. It's going to equal 10. Does my right-hand limit exist? Yes, it does. It equals 30. Do they equal each other? No. 10 does not equal 30. So guess what? You could say this. The limit as x approaches 2 of f of x does not exist. And I'm going to be fine with that abbreviation. I think actually, honestly, on the AP test, they're probably fine with it, but probably just spell it out, right, just in case. So the limit doesn't exist. That's one of the cases where the left-hand and right-hand limits don't equal each other, okay? Another case is actually, you've seen these kinds of graphs before. Let me go over here. Check this out. Let's say I have this graph. I can talk about vertical asymptotes now. And let's say that is, we'll just keep using 2 here. Does the limit exist at 2 there? No, because the limit doesn't exist. Is my y approaching any number here? It's not. It's going higher and higher and higher and never coming back down. Mr. Ishida, it's approaching 1 million. Yeah, for a little bit, and then it's going to pass 1 million, and then it's going to go on to 1 trillion, right? So we are, our left-hand limit, not only do they not equal each other, but they don't even exist. So here's another case, another kind of graph where the limit does not exist. So I can write, the limit as x approaches 2 of f of x does not exist in this case also, okay? So we've got 2 cases, one where the limits do exist but don't equal each other, another one where the limits don't, the one-sided limits, I should specify, those one-sided limits don't exist. And then there's a weird, freaky one. I'm going to tell it to you. Actually, it'd be interesting for you to graph it if you have your calculators or Desmos. If you graph this function, it is wackadoodle. If you have f of x equals sine of 1 over x, it's crazy town. You can turn off the video and just graph it and then check it out. I'll show it right here. It looks like a sine curve, and then it just goes crazy around the origin, okay? So here, I don't really have a great way of explaining this one. Luckily, it never comes up. But the limit doesn't exist at 0 here because the y value is supposed to be approaching some number. And if you zoom in on this, you'll see the y's never approaching number. It's just bouncing manically between -1 and +1. So this is another very obscure, very rare case where the limit as x approaches 0 of f of x does not exist, okay? Those are the 3 cases. If the y value doesn't settle down, if one or both of the one-sided limits are going to infinity, or if the one-sided limits do exist, but they don't equal each other. I think I got two things left to say on this. One is this. You know what? If there's a cheesy kind of like kid way to think about this, but we've already done refrigerator magnets, right? So you want to know when a limit exists in the graph form? If your fingers touch, okay? Do I have it? Oh, yes, I do. So check this out. Over here, does a limit exist? Well, yeah, let's see. Will my fingers end up touching? Beep. Yes, they do. So the limit does exist, okay? And here, check it out. Yeah, can you tell the one-sided limits they both exist and they are equal, so limit exists, right? And then the other thing that I wanted to say, it's 10 minutes, I know it's a long time to listen to me, is this. You will sometimes see here, no question, any mathematician would write down the limit as x approaches 2 does not exist, okay? You got one going to positive infinity, one going to negative infinity, see ya, doesn't exist. Sometimes you'll see this, where they just kind of want to give you a little more information. Let me show you that one. If you see anything like this, let's say they're both going to negative infinity, okay? Right at 2. Then you will occasionally see this. I'm pretty sure that's in your homework. They'll say the limit as x approaches 2 of f of x, and then they'll write equals negative infinity. Granted, that's not a number, so you can bust them on that, but at least that way you can be like, oh, okay, I guess at 2, there's a plunge downward. And sometimes, if they were going up, it would say just regular infinity, okay? I think you're ready now for the other homework, which is homework on one-sided limits and limit laws. Well, we're not ready for limit laws yet, but you can do everything up to 253 on this, okay? All right, see ya.